Let's look at some practice problems. This is the first practice problem. You can pause the video and try to solve it yourself. Okay, so now I'll walk you through the solution. The question is, Jack spends 1/4 of his salary on house rent, 1/3 of salary on food expenses, and 1/6 of salary on all other expenses. He's left with $600. What is his total salary? Okay, so what are we supposed to do? We are supposed to find out total salary of Jack, right? So let's say Jack's salary is X, right? Okay, because that is the variable we have to find out. Okay, and what does he do when he receives X salary? He spends 1/4 of his salary on house rent, so his expenses are 1/4 X by 4 on rent, plus X by 3, 1/3 of his salary on food expenses, and 1/6 of his salary on all other expenses, right? So in total, how much does he end up spending? So he ends up spending X by 4 plus X by 3 plus X by 6, right? So we need to get a common denominator. So the common denominator will be 12, right? So that means here we are talking about 4 becomes 12, that means X becomes 3X, multiplying by 3. Here we are multiplying by 4, so it is 4X. Here multiplying by 2, so it becomes 2X. So this is 3X plus 4X plus 2X is excuse me, so 3X plus 4X plus 2X is 9X by 12, right? So that is we are talking about 3X by 4. So this is his total salary expenses. And what is he left with? He is left with $600. So that means $600 is what remains with him after he has spent all his money on expenses. So that means this was the salary he received minus all his expenses, which is 3X by 4 is equal to 600. So this is the equation that we get. He receives salary X, he spends total expenses, his total expenses are 3X by 4. Whatever remains is his savings, which is $600, right? So we solve this equation now. Let's multiply everything by 4. So you get 2400. 2400 is equal to 4X minus 3X. So X is equal to 2400. So his salary is 2400. Okay, let's verify this. So let's say if his salary is 2400, what will be his house rent? Rent will be 1/4, which is $600, right? 1/3 of his salary on food expenses. So food expenses will be 1/3 of 2400, which is 800. 1/6 of his salary on all other expenses. So 1/6 means $400, right? So add them up. 800 plus 800 plus 600 plus 400. So he ends up spending about 1800 in total. So he receives 2400 minus he spends 1800, he is left with 600. So that is correct, right? So the equation is 600 is equal to X minus 3X by 4, and the salary Jack earns, the value of X is 2400, the correct solution. The second problem, you can pause the video and try to solve it on your own. Okay, so let's look at the solution. So the problem is like this. 10 years ago, X was twice as old as Y. 15 years hence, X will be 4 by 3 times as old as Y. What is the sum of their ages today? So as you can see, we have two variables, age of X and age of Y, and we are asked to find out the sum of their ages. So once we figure out individual values of X and Y, we'll be able to find out their sum. So we basically need two equations because we have two variables. Let's say X is X years old today. So the equations, how do we form the equations? We'll convert this information into equations. So what we do is 10 years ago. So let's say if X was 10 years, X is X years old today. How old he was 10 years ago? He was X minus 10 years old, right? So 10 years ago, X was 3 times as old as Y. How old is Y? y was y minus 10 years old. So this is one equation that we get, which is basically x minus 10 is equal to 3y minus 30. So that means x is equal to 3y minus 20. Okay, this is one equation that we get. Okay, the second equation we get is 15 years hence, that means x plus 15 years hence, x is going to be 4 by 3 times y's age, and y is going to be y plus 15, right? Now this is the second equation. Let's solve it further. Let's simplify this. So this, we know that we have a 3 in the denominator, so we'll have to multiply both the sides of this equation by 3. So what we get is 3x plus 45 is equal to 4y plus 60, correct? Okay, so that means we get 3x is equal to 4y plus 15, right? Okay, so now in one equation we have x, the other equation we have 3x. So multiply this equation by 3 and substitute. So basically we are doing the substitution method. So we know 3x is equal to, from the first equation, 3x is going to be 9y minus 60. This is from the first equation, this is from this equation. Okay, and we know that 3x is also equal to 3x is going to be equal to 4y plus 15. So this is the first method we are using, correct? 3x is equal to 9y minus 60 is equal to 4y plus 15. Now we'll only concentrate on this part of the equation, right? So what do we get? 9y minus 60 is equal to 4y plus 15. So let's get this 4y from right hand side to left hand side. This becomes 5y. So that means 9y minus 4y, so which is 5y, and this 60 minus 60 from here to here, it becomes 650. No, sorry, plus 60. So we get plus 60 plus 75 plus 15 is 75, right? So that means y is equal to 75 by 5 is equal to 15. So once we know y is equal to 15, we can put it in any of these equations. We know that x is equal to 3y minus 20. So x is equal to 3 times y, which is 45, minus 20 is 25. So x is equal to 25 and y is equal to 15 are the individual ages of x and y, right? And the sum of their ages is going to be x plus y is equal to 40. Now how do we verify this, whether this answer is correct? Well, let's look at 10 years ago, x was thrice as old as y. So how old was x 10 years ago? X was 15 years old and y was, okay, let's form a table just for simplicity's sake. Let's say this is today, 10 years ago, and this is 15 years hence, right? So today x is going to be what do you find out? X is 25 years old and y is 15 years old. Okay, 10 years ago x was 15, y was 5. 15 years hence x is going to be 40, y is going to be 30. Okay, let's look at this. 10 years ago x was thrice as old as y. 10 years ago x was 15, y was 5, so x was thrice as old as y, so this is correct. 15 years hence x will be 4 by 3 times as old as y. 15 years hence x is going to be 40, which is 4 by 3 into 30, right? So 40 is equal to 4 by 3 into 30, so that is also correct. So this equation, the solution that we have got is correct, and the sum of their ages will be 25 plus 15 is equal to 20. 45 plus 25 plus 15 is equal to 40. Okay, this is a quantitative comparison question. So we are given 2x minus y is equal to 11 and 11y minus x is equal to 5, and we are supposed to find out which quantity is higher, which quantity is greater, x is greater or y is greater. So pause this video and try to do it on your own. Okay, so let's look at these equations. We have 2x minus y is equal to 11 and 11y minus x is equal to 5, right? So we have two equations, two different equations, and we have two variables, so you should be able to find out the value of x and y individually. So let's use substitution method, right? So let's say or let's get rid of x. That is easier because we have 2x here and negative x here. So basically if you rewrite this equation, 11y minus x is equal to 15, multiply this by 2, let's say, so it becomes 22y minus 2x is equal to 10, and this equation remains like this. Let's keep it like this, 2x minus y is equal to 11. Now we have 2x on both sides, 2x and minus 2x, right? So let's add these two equations. So when you add two equations, the third equation that you get, that also holds true. So that means we get 2x minus y plus 22y minus 2x is equal to 11 plus 10, right? So minus 2x and 2x get cancelled. So what do we get? 21y minus y plus 22y. 21y is equal to 21. So that means y is equal to 1. So we are able to get one variable. We'll get the other variable. X is going to be y. What? You can, let's put y is equal to 1 in any of these equations. Let's put y is equal to 1 here. So we get 11 y, that is 11, minus x is equal to 5. So x is equal to 11 minus 5, which is equal to 6. So x is equal to 6 and y is equal to 1 is the solution for this. And if we compare 6 and 1, we know 6 is greater than 1. So this quantity is greater than this quantity. The option is A. Let's look at the next question. You can pause the video and see if you can solve this. Okay, so we know A, B and C are three numbers. If x divided by a plus b is equal to y divided by b plus c is equal to z divided by c plus a, then find x plus y plus z. Okay, let's look at this. We have x divided by a plus b is equal to y divided by b plus c is equal to z divided by c plus a. And because the ratio of all these things are common, so let's call it k as a constant, because the ratio is going to be constant, right? So all these things are equated to k. So what we get is x is equal to ak plus bk, right? Y is equal to, I'm only looking at this and this, right? Now if I look at this and this, that means y divided by b plus c is equal to k. So I get y is equal to bk plus ck, and similarly I get z equal to ck plus bk, right? So now I'm asked to find out x plus y plus z, which is ak plus bk plus bk plus ck plus ck plus bk, right? So you will see that ak is coming twice. See, there's one ak here, there's one this is ak, this is ak, and this is also ak. So there are two ak's, there are two bk's, and there are two ck's also. So that means we get 2 ak plus 2 bk plus 2 ck, which is same as 2 k, which is common, a plus b plus c. So if a and b are three given numbers, and if x divided by a plus b and y divided by b plus c and z divided by c plus a result into a constant, then x plus y plus z is going to be 2 into that constant, and in bracket a plus b plus c. Okay, so let's look at question number 5. You can pause the video and try to see if you can solve this. Okay, So the information we have is that x, y less than 0, right? So x and y, the product of x and y is negative. That means either x is positive or y is positive and the other number is negative. The only way we can get a negative product is when one of the numbers is negative, right? If you multiply two negative numbers, you will get positive product. Multiplication of two positive numbers will get positive product. So here, because we know that the product is negative, one of the numbers has to be negative, right? And we are asked to compare x plus y square and x minus y square, right? So let's look at this, the three special products that we studied. What do we know about x plus y square? We know that x plus y square means x square plus y square plus 2x. And what do we know about x minus y square? We know that x minus y square is x square plus y square minus 2xy. Sorry, this is 2xy, right? So we are asked to compare these two quantities. So as we know, x square and y square are present on both sides. So effectively what we are saying is that we are asked to compare 2xy and minus 2xy, correct? Whichever is higher, whichever is greater, that quantity will come out to be greater. And what do we know about xy? We know that xy is negative, right? So x square and y square anyway is going to be a positive number. Let's say it's going to be a positive number k. Okay, so we are talking about k plus 2 times what is xy? Xy is a negative number. So we are talking here, this quantity is some positive number plus 2 times some negative number, whereas here on the right hand side it is x plus y square, which is, let's call it k minus 2 times some negative number, correct? So you will see that effectively what we are doing is we are subtracting a negative number here. That means we are adding, this is k plus something, on this side it is k plus something, and on the left side it is k minus something, correct? Why? Because k plus 2 times negative number. So we are basically subtracting some negative number from k. So we will see that the k value of k is same on both sides. On left hand side we have k minus something, right hand side we have k plus something. So we don't need to worry about what that value is, but we can always say that the quantity on the right hand side is going to be greater. So we will say x minus y square is greater than x plus y square. The answer here is B. Let's look at this question. You can pause the video and see if you can solve this. Okay, so let's compare that with the standard form of quadratic equation. A is x square plus bx plus c. We get that a is equal to 2, b is equal to 5 and c is equal to 3. And we can use factorization method for this. We have to find out two numbers whose product is this into this, 2 into 3, product is 6 and sum is 5, right? So what would those numbers be? Product is 6 and sum is 5. The numbers are going to be 3 and 2, right? So let's rewrite it. 2x square plus, we'll split this 5x into 3x plus 2x, 3x plus 2x plus 3 is equal to 0, correct? So we'll look at these two terms separately and we'll look at these two terms separately. What do we have common in 2x square plus 3x? We have x common. So what we have inside the bracket is 2x plus 3, correct? And in 2x and 3 we don't have anything common, so we say 1 into 2x plus 3. So as you remember from one of the previous slides, these whatever we have in the brackets will always come out to be the same thing, right? So we can take it as common. So we have 2x plus 3 and what remains is x plus 1 and x plus 1 is equal to 0. That means 2x plus 3 is equal to 0 or x plus 1 equal to 0. That means x is equal to minus 3 by 2 or x is equal to minus 1. Right? You can also try to solve this by splitting this as 2x plus 3x instead of 3x plus 2x. You will ultimately get the same answer. Another way to solve is you can use that formula minus b plus or minus under root b square minus 4ac divided by 2a. We have the values of a and b and c, and you will get the same solution at the end of any of these methods. Okay, so let's look at the next problem. You can pause the video and solve this problem. Okay, so let's look at the solution. A 2-digit number when multiplied by a number 7 smaller than it gives the product as 120. Okay, what is the number? Okay, let's say that number is x, right? So it's a 2-digit number. Okay, that's fine. A 2-digit number x when multiplied by a number smaller than number 7 smaller than it. So that means x into a number 7 smaller than it, that means x minus 7. X into an x minus 7 gives a product of 120. Okay, so we will see that we get a quadratic equation. We get x square minus 7x is equal to 120. So that means x square minus 7x minus 120 is equal to 0. We need to find out two numbers whose product is 1 into 20, 1 into minus 120, whose product is minus 120 and whose sum is minus 7. Right? Now this can get a little tricky with the negative numbers, but let's look at it. So what would be the factorization of 120? Don't worry about this negative number. Let's factorize only 120. So what are the factors? 1 and 120, 2 and 60, 3 and 40, 5 and 24, okay, 6 and 20, 7, 8, so it could be 8 and 15. Right. Okay, now look at it. 8 and 15, what is the difference? 8 and 15, the difference is minus 7. Difference is 7. So if we write these products as, instead of 8 and 15, we write 8 and minus 15, let's say. Okay, so what will be the product of 8 and minus 15? We'll get a product of minus 120. What will be the sum of 8 and minus 15? The sum of 8 and minus 15 will be minus 7. So 8 and minus 15 is how we have to split this term. Correct. So what we get is x square plus 15x. It will be x square plus 8x minus 15x, which is basically minus 7x, minus 120 is equal to 0. Right? So look at these two terms. What do we have common? We have x common. So we get x and x plus 8. Right? So we get x and x plus 8. From here, what do we have common? We have, let's say, minus 15 common, right? Minus 15 common. So what do you get? X plus 8 common again. Right? In case you don't understand what is going to be common, just look at this term, because ultimately this term is going to be common in these two terms. So x plus 8 is common in both. So you get x minus 15 into x plus 8 is equal to 0. That means either x is equal to minus 15, x is equal to plus 15, or x is equal to minus 8. Right? And what do we know? We know that x is a 2-digit number, so it cannot be minus 18. So it has to be 15. So 15 is the number we are talking about. This number, let's verify the answer. We know that 15 is the number. What is the number smaller than 7, smaller than this? That is 15 minus 7 is 8. Right? The product of these two numbers, 15 into 8, is equal to 120. And here also we have 120. So that means our answer is correct, and the answer is 15. Let's move to the next question. You can pause the video and try to solve it. Okay, let's look at the solution. We are being asked to find out the solve for modulus of solve for x when we know that modulus of x is equal to x plus 6. Then what will be the value of x square plus 3x? Okay, let's look at this first. Modulus of x is equal to x plus 6. Now one thing that should come, strike you immediately is that if x is a positive number, so let's say x is equal to 3, what is going to be a modulus? It is always going to be the same number. So that means modulus of x is equal to x for any positive number. But here we have modulus of x is equal to x plus 6, right? So x, that means x cannot be a positive number, because if x were a positive number, this equation will not hold true. That means x has to be a negative number, correct? Positive number or 0. So it is definitely not positive, it is also not 0, it is definitely a negative number. So that means modulus of x and x are separated by how much? We know that difference between the two is 6. So that means they will always be separated, equidistant from 0, right? So this is going to be x, this is going to be modulus of x, and the difference between them is 6. That means x will have to be negative 3. Another way to look at this is, because x is going to be negative, we can say that modulus of x is going to be negative of x, right? Let's say for example x is equal to minus 5, so modulus of x will be 5, which is the same as negative of negative 5. That means negative of x, correct? So we'll substitute modulus of x is equal to minus x here in this equation. When we do that, what do we get? Minus x is equal to x plus 6. So that means 2x is equal to minus 6. So that means x is equal to minus 3, correct? So either way you'll find out that x is equal to minus 3. And then what they are asking is this quantity. This quantity is x square plus 3x. If x is equal to minus 3, x square is going to be 9, 3x is going to be minus 9, right? So this quantity is going to be 0. So the answer to this question is 0. Let's move on to the next question. You can pause the video. Okay, so now what we have is, we have two things. X lies between 1 and 10 and inclusive of both values, because we have 1 less than or equal to x, x less than or equal to 10. Okay, so we have x falling between 1 and 10 inclusive of both values, y falling between minus 1 and 5 inclusive of both values, right? And we are asked to compare minus 15 and xy. Okay, so we'll see that x falls between 1 and 10 all inclusive, so x will always have to be a positive number, whereas y, the range of y goes from minus 5 to 1. So it is possible that it could be positive or it could be negative. It is both, right? Do we know anything about x or y? We don't know anything else. We just know that they fall in this particular range. So let's consider two equations, like two possibilities. X is always going to be positive, y is going to be positive, and x positive, y negative, or x positive and y is equal to 0, right? Y is equal to 0 is also possible, whereas x is equal to 0 is not possible. Okay, so what is going to happen to value of xy in either of all these cases? So x positive, y positive, xy is positive, x positive, y negative, xy is negative, x positive, y 0, xy is 0, right? And we are comparing them with minus 15. So if it is this case, so xy will be greater than minus 15. If it is this case, we don't know. because x could be negative, but it could be less than positive minus 15, or it could also be a negative number that is greater than minus 15. So we don't really know anything here. If x is equal to 0, it will be xy is equal to 0, then it will be greater than minus 15. But because of this particular case, we are not 100% sure whether in all these cases we'll have xy greater than minus 15 or not. So because of that, and because we don't have any other information, we conclude that we are not able to answer this question from given information, and the answer is D. Okay, so let's look at this problem now. You can pause the video and see if you can solve this. Which of the following statements are equivalent? So we are given three inequalities, and we are asked to find out which of them are equivalent. Okay, let's look at the first one. So we get minus a less than absolute value of x less than a, right? So let's say this is the number line, this is 0, this is going to be a, this is going to be minus a. And what this inequality is telling is that modulus of x is always less than a. Just look at only this part. Modulus of x is always less than a. Okay, so that means we are talking about value of x, modulus of which will fall only in this area. So x could be in this area, or x could also be in the negative region, not including a and minus a. We are talking about this particular region where x can reside, right? So let's say x can come here, and we'll also compare another situation where x can come here. Okay, so this much we know from the first inequality. From the second inequality is given as x square less than a square. Now let's look at this. If x falls here in this area, we are now comparing whether these two inequalities are same, because we are that is the question, which of the following statements are equivalent. So we are seeing whether these two inequalities indicate the same thing. So we are talking about here we saw that there are two possibilities. X could be a positive number, x could be a negative number. If x is positive number and a is obviously positive, right? So and x is going to be falling before a, so that means we know that x is less than a. If x is less than a, we can say that x square is less than a square, right? Okay. If x is going to be negative, but it is still falling, in this region between minus a and a, we can still say that x square, which is the same as it doesn't really matter, because we are talking about x square, it doesn't really matter whether x is in positive region or negative region. So even if it is falling here, its absolute value is going to fall in this area, and then also we are going to maintain this equation inequality as x square less than a square. So that means both these things are indicating the same relationship between x and a. So these two statements are equivalent. Let's look at the third one. 1 by x less than 1 by a. 1 by x less than 1 by a. We don't really have any good way to compare this inequality with the other two inequalities, because other two inequalities we are able to plot them on a number line, whereas here we are not able to do anything. So that means this inequality may hold true or may not hold true, but that is not the question. We are just we are just asked to find out which of these two are equivalent inequalities. So our answer is A and B, 1 and 2. Okay, so let's move to the next question, question 11. What is the greatest value of x for which 5x minus 10 into x minus 1 is equal to 0? Okay, you can pause the video and try to solve this. Okay, let's look at what we have. We have 5x minus 10 into x plus 1 equal to 0. So that means 5x square plus 5x. So I am doing 5x into x and 5x into 1. Now I'll do minus 10 into x, which is minus 10x, and then I'll do minus 10 into 1, which is minus 10. This is equal to 0. So we get a quadratic equation 5x square minus 5x minus 10 is equal to 0. We'll see that 5 is common, so we'll just get rid of it. That makes it very easy to solve. So that means the equation is x square minus x minus 2 is equal to 0. So we have to find out two numbers such that the product is equal to the coefficient of this into coefficient of this, which is 1 into minus 2, which is product is going to be minus 2 and sum is going to be minus 1, right? So those two numbers are always are going to be minus 2 and 1. Minus 2 into 1 is equal to minus 2, and minus 2 plus 1 is equal to minus 1. So though that is the only combination of numbers that will give us product as minus 2 and sum as minus 1. So we'll just split it. We'll say x square minus 2x plus x. So we rewrite minus x as minus 2x plus x. X square minus 2x plus x minus 2 is equal to 0, right? So we'll look at these two terms. What do we get? X into x minus 2. The same thing will have to be common here. Plus 1 into x minus 2 is equal to 0. So that means we get x plus 1 into x minus 2 is equal to 0. That means x is equal to either minus 1 or x is equal to 2. Correct? And what is the question? What is the greatest value of x for which this equation holds? So the greatest value of these two is between minus 1 and 2. We have 2 as the answer. So 2 is the greatest value for which this equation holds. Okay, so let's look at this last question. Find the range of values of x, and we are given 4 inequalities. So as you know, inequalities and absolute value, they represent range on a number line. So we are asked to find out the range of these inequalities. So give it a shot on your own. Pause the video. Okay, let's look at the first question. We have 2 minus x greater than 10, right? See, the way to solve this type of problems is that we know absolute value, like for example, absolute value of 5, absolute value of x is equal to 5. It could mean x is equal to 5 or x is equal to minus 5. So there are two possibilities, right? So what we do is, whenever we want to get rid of the absolute value sign, without that we'll not be able to solve anything. So we have to first get rid of the absolute value sign, and we consider two cases, one positive case, one negative case. So what I mean by that is, let's split this inequality into two inequalities. We'll write 2 minus x greater than 10. This is the first inequality. We just ignore the absolute value. Second, we make whatever is there inside the absolute value sign, we just take a negative of that. So we take minus 2 plus x greater than 10. So these two inequalities are derived when we get rid of the absolute value. So what we do is 2x minus 10 is greater than 10, sorry, 2 minus x greater than 10 and minus 2 plus x greater than 10. This is how we get rid of the absolute sign, and then we solve these inequalities individually. So that means first one will tell you that 2 minus x greater than 10. So we get x on this side and 10 on this side. So what we get is 2 minus 10 greater than x. So that means x is less than minus 8. Correct? Second one, what does it tell us? It tells us that minus 2 plus x greater than 10. So minus 2 from left hand side we take to right hand side. So we get x greater than 12. So both these each of these inequalities will give us one range, and combined together we are talking about, see this is the number line, the points of interest will be minus 8 and 12. We are talking about all x that are greater than 12. So we are talking about this range till infinity. We are talking about all x less than minus 8. So we are talking about this range until negative infinity. So this with the absolute value, we are talking about two ranges. One range is less than -8, the other one is greater than 12. Okay, let's look at the second equation. Okay, what do we have? We'll follow the same method. Modulus of 10 minus x less than 20. So we split it into two separate inequalities. One is 10 minus x less than 20. The other one is minus 10 plus x less than 20. Right? The first one tells us 10 minus x less than 20 means, let's say x we get from left hand side to right hand side and 20 we get from right side to left side. So we get 10 minus 20 less than x. So that means x is greater than minus 10. Correct? The second one tells us minus 10 plus x less than 20. That means x is less than 30. Correct? So both these together, what are we talking about? We are talking about 0, 30 and minus 10. X greater than minus 10, so everything to the right of minus 10, and x less than 30. So anything between minus 10 and 30 is what we are looking for. Right? What we can do is, this is an exercise for you. You can pick any number, 0 or any positive number between 0 and 30, or any negative number between 0 and minus 10, and see whether this holds true. We can do it for any of these problems actually. Right? Okay, let's move to the third one. Okay, third one is, so we have 2x plus 10 absolute value greater than x minus 5. Great. So first equation we get is 2x, first inequality, 2x plus 10, let me just rewrite it. Okay, 2x plus 10 greater than x minus 5. So let's get x from here to here, or 10 from here to here. So we get x greater than minus 15. This is one range we get. Second one will be, let's negate whatever is there inside the absolute value sign. So you get minus 2x minus 10 greater than x minus 5. Right? So let's say we are getting this minus 2 from left hand side to right hand side, move minus 5 from right to left. So we get minus 10 plus 5 greater than x plus 2x. So that means minus 10 plus 5 is minus 5, minus 5 greater than 3x. So that means x is smaller than minus 5 by 3. So x is less than some negative number. Okay, so we are talking about this number line where the points of interest as minus 5 by 3, the other number is minus 15, and x has to be greater than minus 15. So to the right side of minus 15 and to the left side of minus 5 by 3. So this particular region is what we are talking about. Okay, let's look at the last question. We have modulus of 20 minus x less than x plus 10, right? So first inequality we get is 20 minus x less than x plus 10, right? So let's get x on the right hand side. So it is 20 minus 10 less than x plus x. So 20 minus x is 10, 20 minus 10 is 10, 10 less than 2x, or x greater than 5, right? So we get this inequality. Second one, we'll start with a negative of what is there in the absolute value term. So we get negative of 20 plus x less than x plus 10, right? So as you will see, on both sides we have x common, right, and minus 20 will always be less than 10. So this equation does not really mean much. So that means we don't have the second confining range, we have only one range, which is x greater than 5, and we are talking about 0 here, 5 here. We are talking about all the numbers to the right hand side of 5, from 5 to infinity. So friends, that's it for the first class of algebra, and I look forward to meeting you in the second class.